Hi everyone, I'm Sashank, third year computer science undergraduate at VIT Chennai. This is technically the day 2 of LLM fine tuning, but yesterday I was unable to do some of network issues, so I will consider this as day 1 of progress updates. In the day 0 video, I was setting up the context for this experiment. I missed to say one important thing, that I will be focusing more on fine-tuning small language models which have parameters below 1 or 2 billion, so that it will be a faster experiment for me to test and fine-tune. Since it is clear, I will give my updates. The first thing is, what I did was I found out existing benchmark dataset which was called CS bench, which contains questions from operating systems, computer networks, computer architecture, DBMS, etc. And it had 4 types of questions, which were MCQs, true or false, which were tagged as assertions, and fill in the blanks and open-ended questions. I took all these and then only considered MCQs and assertions because judging the fill in the blank questions and open-ended questions are kind of tricky and may not be the best metric to measure a model's performance right now. So I started with a simple exact option matching metric, where I took 5 models which were small 135 million parameters, small LM2 360 million parameters, and then Quen3 with 0.6 billion parameters, and then Quen 2.5 with 0.5 billion parameters, and TinyLlama and Gemma with 270 million parameters, and then had a common prompt template which was explaining all the rules, and it should only output a single option, which was either A, B, C, D for multiple choice questions, or A or B, which was true or false for assertion type of questions. By testing the models with these set of questions, the total data set had around 4,000 questions, and then by filtering only the MCQs and the assertion type of question, I ended up with around 1900 questions. And by testing these questions with the models, Quen3 with 0.6 billion parameters performed the best with an accuracy of around 33%. The remaining models performed close, but which were ranging from 20%, which was small 135 million parameters model, and then small again with 27, and then Gemma with 30, and TinyLlama with 31, and Quen 2.5 with 32%. I could also see a few interesting observations, which were, since the probability of getting a question right is 25%, even if the model had just guessed option A for all the question, there is a high chance that it can get like accuracy of 25%. And I could clearly see that some models were doing it. So this was not a detailed assessment of the detailed assessment of the model's performance, but really basic one. So the next steps can be to assess every option's occurrence or prediction, like how much what is the distribution of answers in the data set, and then what is the amount of what is the occurrences of A, B, C, D by the model's answer, etc., and then finding a distribution of them, so that we can get a more accurate, detailed report on the behavior of these models. And then the second thing which I did was to collect more data sets, because these questions were not reference to any source from where they were taken. So in India we used to have GATE as a common examination for postgraduate studies. So what I did was I collected around 15 years of computer science papers. Each paper has around 65 questions. So I would get around 2000 questions approximately, and then I could use this as a benchmark on every step of the fine-tuning process, so that it will be really accurate based on the books, the syllabus. The GATE uses are like really close to what the books which I refer to are based on. So the next steps is going to be extracting JSON or structured question option format from the GATE questions, because right now I only have the GATE as a PDF. I also converted them to Markdown format, but I don't really have them in a structured JSON or a CSV or like a working format which I can use to test it, like what I did, what I had for CS Bench. So the next step is going to be to extract proper questions, proper options, and the answer option from the answer key, and then mapping them and then putting them into a single file is going to be a tricky task, since everything is not so certain. We can have issues in OCR, we can have issues in getting the tables in the question into the prompt, etc., etc. So I'm excited to solutions for this. A third thing I did was I also thought about including those who fill in the blank and open-ended questions, because why to waste data? So I also thought of few ways to judge these open-ended fill in the blank questions. Few methods I read upon are the basic one is just just direct matching the answer, which is not so great. And then the second method was to find embeddings for both the generated response and the actual answer, and then try to find the similarity score between those. And then the third method was to like search keywords in the having a keyword answer keyword set, and then searching these keywords in the generated response. Fourth method was to use an LLM, but those things are not so great at comparing, so we can just neglect the option. Yeah, so we have so many methods, but we have to try out with different methods and then see the trade-offs on which does the best to compare to answers. So the next steps is going to be getting structured question answer options format from the GATE questions, and then the second is to find a proper way to compare open-ended questions. The third thing can be to get a detailed analysis report on the options of the data set and also the options that the models are predicting. That's it for day one. I will see you on the next day. Peace.